What if the energy transition we were promised was a lie, based on a single fundamentally flawed element? For over a decade, we were assured that lithium was the future, the undisputed king of energy storage. Governments bet trillions, corporations shifted entire supply chains, and investors staked their fortunes on the belief that lithium-ion batteries were the final destination. This wasn't just optimism, it was global dogma. But the dirty secret is that lithium-ion was never the endgame. It was a desperate bridge technology, and one company, Samsung, has just detonated that bridge. Not with an incremental improvement, but with a full-scale replacement of the most important energy material on Earth. The core technology insiders are whispering about has a nickname that says everything you need to know about the scale of the destruction: the silver bomb. This isn't marketing hype. This isn't a lab experiment confined to a university bench. This is a real scalable battery breakthrough, and if it scales, lithium as we know it may never recover. The timeline for the death of lithium isn't measured in decades, but in a compressed 5 to 10-year market window. Are you ready for the total dismantling of the energy sector's trillion-dollar foundation? Or will you be caught holding assets that become worthless overnight? This is not a future prediction based on conjecture. This is a breakdown of the technological and geopolitical consequence of a shift that is already in motion. For the last 3 decades, lithium ruled the world. Not oil, not gas. Lithium. Every modern device you rely on, smartphones, laptops, electric vehicles, EVs, power tools, grid energy storage systems, depends on lithium-ion batteries. They didn't just enable technology. They defined an era of mobility and connectivity. Entire global economies reshaped themselves around the search, extraction, and refinement of this single element. Investors poured trillions into lithium-based companies and mining operations, from the salt flats of Chile to the deserts of Australia. Lithium became a geopolitical commodity, a new form of power, triggering quiet fights for access to reserves and control over manufacturing. But the lithium empire was built on a time bomb of severe limitations. And today, we are going to expose the critical weaknesses that Samsung's new technology exploits with surgical precision. In this deep dive documentary, we're going to break down the dirty secret, why lithium was always a temporary solution of bridge technology plagued by scarcity, environmental devastation, and fundamental safety flaws. The revelation: what Samsung's silver bomb actually is, a silver-enhanced solid-state architecture, and why the simple replacement of liquid with solid electrolyte is the single biggest threat to the entire battery supply chain. The consequence: why this technology threatens over half a dozen global supply chains, from South America's mining economies to Asian refining giants. The bottom line: who wins, who loses, and which nations and corporations will be wiped out when this technology scales. This is not merely an upgrade. This is the extinction-level disruption of the 21st century's most important energy technology. Lithium's dominance, hailed as the miracle metal of the 21st century, hides some serious fundamental flaws. These aren't minor technical hurdles. They are intrinsic limitations so deep that scientists and engineers have been searching for stable, scalable, and safer alternatives for decades. The dirty secret is that the lithium empire was always destined for obsolescence. 1. Lithium is scarce and unevenly distributed. Geopolitics of scarcity. The first lie of the lithium age is the idea of global supply security. Lithium doesn't exist everywhere. Its presence is highly localized and concentrated, leading to a new form of resource geopolitics far more volatile than oil ever was. Over 75% of global lithium reserves are concentrated in a handful of regions, famously known as the Lithium Triangle: Chile, Argentina, and Bolivia, and Australia. Add China to that list, which, while not having the largest reserves, dominates the processing and refining capacity. This creates profound dependency. If a handful of countries, some with volatile political climates or shaky regulatory systems, control 3/4 of the supply, they effectively control global pricing, production output, and the economic fate of every major EV manufacturer in the world. This is why lithium quickly became geopolitical leverage, forcing Western nations to scramble for long-term supply contracts and pushing the price of a critical input into a continuous cycle of boom and bust. The inherent scarcity and uneven distribution created a supply chain risk that was simply unsustainable for a foundation of global energy. The world cannot afford to trade dependence on Middle Eastern oil for dependence on South American lithium. Lithium mining is environmentally brutal, the green lie. The second lie of the lithium age is the green narrative. Electric cars may be clean on the road, but the process of extracting the element that powers them is environmentally devastating. Lithium mining, particularly the brine extraction method used extensively in the lithium triangle, is far from sustainable. This process involves pumping massive amounts of mineral-rich brine into sprawling, shallow evaporation pools that can cover tens of square miles. This process consumes enormous amounts of water in arid regions like the Atacama Desert, one of the driest places on Earth. Extracting a single ton of lithium can require hundreds of thousands of liters of fresh water. This places an unsustainable strain on local water tables, impacting agriculture and basic human access to water. Destroys fragile ecosystems. The vast salt flats are unique and delicate ecosystems. The withdrawal of brine and water fundamentally changes the hydrological balance, leading to the collapse of local biodiversity, often displacing indigenous communities whose livelihoods depend on those resources. Generates massive toxic waste. The chemical processes required to refine the brine into battery-grade lithium carbonate or hydroxide leave behind substantial amounts of chemical waste and toxic residues, posing long-term disposal and cleanup challenges. The paradox is unavoidable. We are fighting climate change by creating environmental ruin elsewhere. This moral and ecological debt adds significant long-term risk and regulatory pressure to the lithium industry, making any cleaner alternative instantly superior. 3. Lithium batteries are dangerous. Thermal runaway. The third and most frightening secret is the inherent danger of lithium-ion batteries. They are, by their very nature, volatile. The primary culprit is thermal runaway, a chain reaction where the heat generated inside the cell exceeds the heat dissipated. Once a single cell overheats due to damage, overcharging, or a manufacturing defect, it rapidly releases stored energy, generating more heat and triggering its neighbors. This leads to the spectacular failures we've all witnessed: smartphones exploding in pockets, laptops catching fire mid-flight, leading to airline safety concerns, electric vehicles requiring specialized, difficult-to-extinguish fire protocols due to the intensity and speed of the chemical combustion. As battery engineers push for greater energy density, the goal of stuffing more energy into less space to increase EV range, the risk of thermal runaway increases exponentially. The liquid electrolyte used in traditional lithium-ion batteries is highly flammable and acts as the accelerant. For grid-scale storage, where thousands of batteries are packed into a confined space, the risk of a catastrophic cascading failure is the single greatest impediment to mass adoption. Safety is not a feature you can patch onto lithium. It's a fundamental vulnerability. 4. Lithium is hitting its physical limits, the innovation ceiling. The final truth is technological. Lithium is simply hitting its innovation ceiling. When lithium-ion technology first emerged, the rate of improvement in energy density was rapid and dramatic. But over the last decade, those improvements have slowed to a crawl. Engineers are now squeezing out smaller and smaller gains at disproportionately higher costs. The technology is maturing, which means it's becoming saturated. The limits are physical and chemical. Slow charging. The speed at which you can safely charge a lithium-ion battery is limited by the risk of lithium plating, where lithium metal deposits on the anode, which degrades performance and increases volatility. Weight and volume. To achieve longer EV ranges, manufacturers must simply add more battery, increasing the vehicle's weight, which reduces efficiency and requires more road infrastructure maintenance. Degradation. The liquid electrolyte constantly eats away at the battery's active materials, leading to inevitable capacity loss and reduced lifespan. Which leads to the definitive, inescapable conclusion that Samsung grasped: lithium cannot possibly power the next energy revolution. It is incapable of meeting the demands for instant charging, zero fire risk, and ultra-long life cycles needed for the coming age of mass storage and truly competitive EVs. And Samsung knows that the future belongs to whoever solves these 4 dirty secrets first. Samsung didn't wake up one morning and decide to abandon lithium out of spite. They did it out of necessity. They spent years watching their competitors hit the same 4 roadblocks in battery development. They realized that the next leap in energy storage required not a modification of the old chemistry, but a complete radical revolution. Behind closed doors, within the highly secretive labs of the Samsung Advanced Institute of Technology, SAIT, a dedicated team began developing an approach so radical it was deemed impossible by many industry veterans. The goal was not incremental improvement, like an extra 5% density or 10% faster charge. The goal was total replacement, the permanent obsolescence of lithium-ion. So what is the silver bomb? The secret sauce. The silver bomb is the culmination of decades of research into a next-generation silver-enhanced solid-state battery architecture. To understand the magnitude of this breakthrough, you must discard the mental image of a battery made entirely of silver. That would be absurdly expensive and impractical. It is something far more sophisticated, far more surgical. Samsung uses silver not as the primary active material, but as the critical conductive and stabilizing component within a solid-state battery structure. They created a silver nanocomposite layer, a proprietary blend of silver-carbon AgC, designed specifically to interface between the cathode and the solid electrolyte. And that surgical addition changes everything about the battery's performance and safety profile. Why silver? The unlocking element. Why did Samsung choose silver, a metal traditionally relegated to jewelry and photography, as the key to unlocking the future of energy? Because silver is not just a conductor. It is the most electrically conductive metal on Earth. No other element offers its unique combination of properties required for an ultra-high-performance solid-state battery, exceptional ion mobility. Despite being a solid, the silver nanocomposite layer allows lithium ions to move through the solid material with remarkable speed and efficiency. This eliminates the core weakness of every previous solid-state attempt. Extreme chemical stability. Silver exhibits low reactivity with the solid electrolytes and the high nickel cathode materials necessary for high energy density. This stability prevents the parasitic side reactions that cause degradation in traditional lithium cells. Low degradation over time, the stability ensures that the battery can handle thousands of charge-discharge cycles without the rapid capacity loss that plagues current EVs and smartphones. In battery terms, this revolutionary combination translates directly into hyperfast charging. The low internal resistance gifted by the silver layer allows the battery to accept and store energy significantly faster, theoretically enabling charges in minutes, not hours. Higher energy density. The stability allows for the use of pure lithium metal anodes and high voltage cathodes, meaning more energy can be packed safely into less space. Unprecedented safety. By eliminating the flammable liquid electrolyte and replacing it with a stable solid, the risk of thermal runaway is virtually nullified. Samsung combined this superior silver-assisted chemistry with the inherent safety of solid-state design. The result? A battery that can potentially charge in 5 to 10 minutes, or 50% more energy than current lithium-ion cells, operates safely at significantly higher voltages, and lasts for significantly longer periods. The naming. Why a bomb? Industry insiders didn't call this development the Samsung solid-state breakthrough. They called it a silver bomb. The name stuck for a reason. A bomb does not improve the landscape. It destroys the existing one. This technology isn't just competition. It represents the functional obsolescence of the entire lithium-ion infrastructure. By solving the 2 existential threats to battery development, the conductivity problem of solid state and the flammability problem of liquid electrolyte, Samsung has created a technology that is demonstrably safer, faster, denser, and more sustainable than lithium-ion. When a replacement technology is superior on every single metric, the market doesn't transition slowly. It shifts violently. The silver bomb isn't a threat to competitors. It is an existential threat to the entire $400 billion global lithium supply chain built on the old, flawed chemistry. This is the definition of disruptive technology. To understand the scale of the disruption and why the world is about to panic, you must first understand the fundamental difference between the lithium age we are leaving behind and the solid-state era we are entering. The core distinction is deceptively simple: liquids versus solids. Traditional lithium-ion batteries are essentially controlled chemical systems submerged in liquid electrolytes. These liquids are what allow the lithium ions to shuttle back and forth between the anode and cathode during charging and discharging. But these liquids are not benign. They are flammable. They are the primary reason lithium-ion cells catch fire, propagating the catastrophic thermal events. Unstable. They react constantly with the electrodes, creating a degradation layer called the SEI, solid electrolyte interface, which permanently reduces battery lifespan and capacity. Temperature sensitive. Their performance drops dramatically in cold climates, and they accelerate risk in warm climates, complicating their use in global applications. Replacing these volatile liquids with solid materials is not just a component upgrade. It is a fundamental re-engineering of battery physics. This by itself creates massive and disruptive advantages that lithium-ion simply cannot match. The undeniable benefits of the solid state. The benefits of eliminating the liquid and using a solid electrolyte, whether it is a polymer or a ceramic, fundamentally redefine what is possible in energy storage. A zero fire risk, safety above all. Safety is the most immediate and critical selling point. No liquid means no fuel for the fire. It means no thermal runaway in the classic sense. The removal of the flammable liquid electrolyte eliminates the catalyst that propagates the catastrophic fires we have, tragically associated with electric vehicles, EVs, and mobile devices. Solid electrolytes are, by their nature, non-combustible. This factor is crucial not only for consumer vehicles, but for large-scale grid storage. Today, utility-scale storage requires expensive cooling systems and complex fire suppression protocols that are costly and difficult to maintain. With the solid state, that layer of complexity and cost vanishes, allowing batteries to be packed more efficiently and safely, instantly accelerating the global energy transition. B. Extreme energy density, the lithium metal anode. The solid state enables the use of an anode material that was a virtually impossible dream in the liquid era: pure lithium metal. A lithium metal anode has up to 10 times the specific capacity of the graphite used in traditional lithium-ion batteries. In a liquid battery, using lithium metal is extremely dangerous because it promotes the rapid formation of dendrites, crystal structures that pierce the separator, causing internal short circuits and fires. However, a solid electrolyte dense and rigid acts as a physical and chemical barrier against dendrite formation. This robust barrier allows engineers to unlock extraordinary energy density, leading to breakthroughs: smaller batteries, achieving the same range with a smaller, lighter battery pack. Lighter devices, reducing the overall weight of the vehicle, crucial for efficiency and road wear. Longer ranges, enabling EV driving ranges that comfortably exceed 600 miles, 1,000 kilometers from a single charge, finally solving range anxiety. This energy density means lighter devices, longer range cars, and the potential for electric aviation that was previously unattainable. C. Multiply longevity and lifespan. As established, the liquid in traditional batteries constantly degrades the active materials, leading to the inevitable reduction in capacity over time. The solid electrolyte is fundamentally more chemically stable. This translates directly into a key consumer benefit: longevity. A solid-state battery degrades far slower, meaning the life cycle of an EV, a smartphone, or a grid storage system is significantly extended. This means fewer replacements, lower lifetime ownership costs, and a smaller overall carbon footprint across the entire usage cycle. If solid-state batteries are so safe, fast, and durable, why haven't they already replaced every lithium battery you own? The answer is a single, unsolvable physics problem. Are you ready for the one flaw that makes all current solid-state attempts useless? The problem that stopped everyone, the conductivity trap. The concept of the solid-state battery has existed since the 1950s. The idea itself is not new, but it has always been halted by one single insurmountable obstacle that has bankrupted dozens of billion-dollar startups: poor conductivity. Lithium ions, which must move to create electricity, simply do not move easily through dense solid materials. Think of it this way: the liquid electrolyte is a fluid, high-speed freeway. The pure solid electrolyte, in its initial form, is a dense swamp. Ions have to force their way through. This poor conductivity caused two existential problems in early solid-state prototypes: impossibly slow charging. The sluggish ion movement meant a battery would take days, not minutes, to fully charge. High internal resistance. The difficulty in moving ions generated immense internal resistance, meaning much of the stored energy was lost as heat, making the system inefficient and volatile at high charging rates. Engineers could make a battery that was safe, or they could make one with high energy density. They could not achieve both simultaneously in a usable product. Samsung. The missing link, the silver solution. This is where the Samsung Advanced Institute of Technology proved that a decade of relentless effort had paid off. Samsung did not invent solid-state batteries. They made them commercially viable. Their solution was the proprietary silver-carbon nanocomposite layer, AgC. This layer acts as a turbocharger within the solid swamp, solving the conductivity problem without compromising the solid-state safety profile. This layer achieves two critical functions: ion transfer acceleration. Being the most conductive metal, silver creates ultra-efficient pathways for ions to rapidly cross the solid barrier, eliminating internal resistance and allowing charging at speeds previously thought impossible in a solid system. Dendrite suppression. The optimized structure of the silver layer helps manage the volume change of the lithium metal during charging, further suppressing the formation of dendrites, even at the high current rates required for hyperfast charging. The silver bomb is, in the end, the missing technological bridge, combining the safety and density of the solid state with the speed and efficiency of silver. This is not just a new battery. It is the validation of a concept that has remained technically unobtainable for 70 years. And now that the final problem is solved, lithium-ion has no defense against obsolescence. Here is where the technical brilliance of the silver bomb collides with economic reality. If Samsung's silver-based solid-state batteries successfully scale, and all internal reports suggest they will, the consequences for the lithium-ion market are not a plateau or a slow transition. This is an extinction-level event. When a new technology outperforms the incumbent on every single critical metric: safety, speed, density, and longevity, the market doesn't politely switch. It collapses the infrastructure of the old system. Lithium demand doesn't just fall. It falls off a cliff. 1. The EV market. The end of lithium's largest customer, electric vehicles, were supposed to be the endless gravy train for lithium miners. But the EV industry is driven by 4 consumer demands that lithium-ion technology struggles to meet: range, charging speed, safety, and cost. Silver-based solid-state batteries outperform lithium-ion on all 4. Range anxiety solved. A 50% increase in energy density allows smaller, lighter battery packs to achieve ranges exceeding 600 miles, 1,000 kilometers. This fundamentally alters consumer acceptance. The 10-minute charge. With ultra-low resistance from the silver nanocomposite, EVs can recharge 80% of their capacity in less than 10 minutes, a time comparable to refueling a gasoline car. This eliminates the largest complaint about electric mobility: zero warranty risk. The elimination of fire risk drastically reduces the liability and insurance costs for manufacturers. Longevity. Battery packs that last 15 to 20 years mean fewer replacements, improving the total cost of ownership. Once major AV manufacturers, like Ford, GM, or eventually Tesla, make the switch to source solid-state batteries, lithium-ion loses its single largest and fastest-growing market. This is the moment the lithium stock market will implode, as speculators realize the future demand curve is not just flattening, but inverting. 2. The consumer electronics market. Immediate obsolescence, while the EV market provides volume. Consumer electronics, smartphones, laptops, and wearables drive the perception of speed and safety. Imagine phones that charge fully in under 5 minutes, last 3 days on a single charge, do not degrade noticeably after a year of heavy use, are guaranteed not to explode or suffer thermal events. For companies like Apple and Google, adopting solid-state technology is not optional. It's a necessary competitive advantage. When one flagship phone offers a 3-day, 5-minute charge cycle, lithium-ion suddenly looks hopelessly outdated. The speed of replacement in consumer tech is brutal, measured in quarters, not years. The minute a scaled solid-state product hits the market, lithium batteries will be relegated to the budget and legacy sectors almost instantly. 3. Grid-scale energy storage. The safety mandate. The final pillar of lithium demand is grid-scale energy storage. The batteries needed to stabilize power grids relying on intermittent solar and wind energy. This sector requires 3 things above all else: stability, safety, and longevity. Lithium struggles here severely. Large lithium battery farms are massive fire hazards, requiring immense cooling infrastructure and complex fire suppression systems. The failure of one cell can take out an entire storage facility. Solid-state excels. The elimination of the flammable electrolyte makes these large-scale installations inherently safe and cheaper to ensure and operate. Furthermore, their superior longevity means utilities can rely on them for decades without costly replacements. The safety mandate alone is enough to push major energy suppliers and grid operators, like those in California or Germany, to mandate solid-state technology as the new industry standard, permanently sealing lithium's fate in the most critical energy sector. The market contagion. Who gets wiped out? The disruption isn't just technical. It's economic and geopolitical. If demand for lithium collapses, the consequences will create a ripple effect of stranded assets and bankruptcies across the globe. A. Countries at risk. Geopolitical destabilization. The lithium triangle: Chile, Argentina, Bolivia. These nations built national strategies, foreign investment, and state revenues around lithium exports. A sharp drop in demand could instantly crash their government revenues, destabilize political systems dependent on mining income, and lead to capital flight, triggering a local economic crisis far worse than any commodity crash. China. China dominates 60 to 70% of global lithium refining and processing. While they have internal programs, the massive capital investment in processing plants becomes worthless if the underlying material is no longer needed. The geopolitical lever China wields over the EV supply chain instantly snaps. B. Corporations and assets at risk. The stranded trillions. Lithium miners and refiners. Companies like Albemarle, SQM, and Ganfeng, which represent billions in infrastructure and investment, will face insolvency. Their mines and refining facilities, built for the lithium-ion age, become virtually worthless. Battery recyclers. The entire future recycling market, based on processing old lithium-ion packs, faces an identity crisis. The recycling of a solid-state battery is different, and the volume of lithium to recycle suddenly diminishes in value. C. Investors at risk. The silent crash. Entire portfolios, mutual funds, and ETFs are exposed to the lithium supply chain. The crash won't wait for the factory retooling. Markets move on anticipation. Even strong rumors of Samsung scaling up will trigger a speculative stampede, causing lithium stocks to enter freefall long before the last liquid battery rolls off the assembly line. This is not competition. This is the mechanism of market extinction. Samsung is not aiming to compete. It is aiming to replace. The silver bomb is not just a technological explosion. It is a supply chain tectonic shift. Lithium isn't just a raw material. It is the economic cornerstone of multiple national strategies and a critical geopolitical lever. If demand collapses, the consequences won't just be felt in boardrooms. They will ripple through sovereign debt markets and destabilize political systems built entirely on lithium export revenue. 1. The geopolitical pivot. From lithium triangle to silver mines for years, the world accepted the high concentration risk of the lithium triangle. The US and Europe were forced to navigate complex diplomatic relations with Chile, Argentina, and Bolivia to secure their energy future. Samsung's breakthrough instantly changes the equation of resource power. If the silver bomb scales, resource control shifts from South American salt flats to a global, far more diversified and established market. Silver, lithium, concentrated scarcity, politically unstable regions, complex extraction. Silver, global commodity, diversified mining across North America, Australia, Mexico, and China, with established trading routes and reserves. This shift alleviates the Western dependence on the lithium triangle, but creates a new dynamic, the silver squeeze. While silver is plentiful, the surge in demand from the battery sector competing with industrial, jewelry, and investment demand will inevitably put massive upward pressure on silver prices, turning it into the next high-stakes investment commodity. The geopolitical risk doesn't vanish. It simply pivots to new markets and new price volatility. 2. The debt crisis for lithium economies. The economic collapse for the lithium triangle states will be immediate and severe. These are not fully diversified economies. Their national budgets and credit ratings are increasingly tied to the projected value and volume of their lithium exports. The domino effect. Investment freeze. News of the silver bomb will instantly halt all future foreign direct investment (FDI) into new lithium mining projects in these nations, stranding billions of dollars of projected revenue. Credit downgrades. Without these future revenues, credit rating agencies will downgrade sovereign debt, dramatically increasing borrowing costs for these governments. Political instability. The crash in national income will lead to severe budget cuts, higher unemployment, and social unrest, potentially destabilizing governments that promise economic prosperity based on the lithium boom. The transition will be a brutal economic reckoning for any nation that failed to diversify its resources beyond the flawed lithium bridge. 3. China's infrastructure investment becomes stranded. China's role in the global supply chain is not mining. It is processing and manufacturing. China controls over 70% of the world's lithium refining capacity and dominates the anode and cathode manufacturing. Their geopolitical strategy was to own the middle of the lithium-ion supply chain, forcing every EV maker in the world to rely on them. The silver bomb vaporizes this strategic advantage. Solid-state battery manufacturing is a fundamentally different process requiring retooling, new materials, and specialized expertise, which Samsung will patent heavily. The vast trillion-dollar infrastructure China built to refine and manufacture the old liquid-based batteries, the gigafactories and refining hubs, will become stranded assets overnight. This is a strategic defeat for China, shifting control of the next generation of battery technology and its associated manufacturing standards, away from them and back toward innovative players like Samsung. The end of the cathode and anode giants, the traditional battery supply chain is segmented. Raw miners supply refiners, who supply specialized material producers, cathode and anode. Cathode materials, nickel, cobalt, manganese. Solid-state batteries still require high-nickel cathodes, meaning some demand for these materials will persist. However, the exact chemistry and coating will change, creating massive turbulence for existing suppliers. Anode materials, graphite. The biggest hit will be the graphite producers. The silver bomb's ability to safely utilize a lithium metal anode means the multi-billion-dollar graphite anode industry is rendered technologically obsolete. The graphite market will suffer a catastrophic collapse as its main purpose in the battery world vanishes. This cascade effect demonstrates that the disruption is not localized to one part of the chain. It is a systemic demolition of the entire infrastructure built on the liquid lithium-ion paradigm. Every market destruction creates opportunity. The implosion of the lithium-ion supply chain does not leave a vacuum. It creates an entirely new landscape dominated by new technology, new resource needs, and new market leaders. While miners and legacy producers are facing extinction, a handful of players are positioned to reap enormous, systemic rewards from the silver bomb. 1. Samsung, the ecosystem dominator. The most obvious and significant winner is Samsung itself. They didn't just invent a better battery. They engineered the technological successor to the digital age's most critical component. Samsung gains immense. 4. Multifaceted leverage. Patent dominance. Their proprietary silver carbon AgC nanocomposite layer, the secret sauce that solved the conductivity problem, will be protected by walled patents. This ensures they control the core technology necessary for a high-performance solid-state battery. Licensing revenue? Competitors who want to catch up from CATL to LG Energy Solutions will likely be forced to license Samsung's fundamental patents. This creates an exponential, low-cost revenue stream, essentially taxing the rest of the battery industry. Industry standard-setting power. By pioneering the scalable solid-state architecture, Samsung is positioned to define the manufacturing and safety standards for the next 2 decades. They won't just sell batteries. They will control the entire ecosystem, dictating the terms of energy storage globally. 2. Silver, the reborn commodity. The second major winner is the commodity itself. Silver. For decades, silver has been overshadowed by gold as a financial asset and by base metals for industrial use. The silver bomb changes that status overnight. While the volume of silver used per battery cell is small, the sheer scale of the global battery market, from billions of smartphones to hundreds of millions of EVs, means the total industrial demand for silver will skyrocket. The new battery segment will suddenly compete fiercely with existing demand from solar panels, industrial soldering, and jewelry. This competitive demand surge will lead to the predicted silver squeeze of the late 2020s. Silver, which is currently mined and traded in a complex market, will see unprecedented price volatility and long-term appreciation, turning dormant silver mining companies and patient silver investors into massive winners. The narrative will pivot. Silver is no longer just a hedge against inflation. It is the conductive lifeblood of the future energy economy. 3. Tech giants and early adopters. Every company relying on energy storage will benefit massively by becoming early adopters of the silver bomb technology. EV manufacturers, companies that secure early supply contracts with Samsung or their licensees, gain an immediate, almost insurmountable competitive advantage. They will be the first to market with 10-minute charge times and 600-mile ranges, while their competitors are still stuck selling heavy, slow-charging lithium-ion models. This will lead to massive market share shifts. Cloud and data centers. Server farms require enormous battery backup systems (UPS). Solid-state batteries eliminate the fire risk and reduce the physical footprint required, saving billions in real estate and cooling infrastructure costs. Consumer brands, Apple, Microsoft, their ability to offer products that are demonstrably safer, lighter, and last 2 or 3 times longer than their competitors' lithium models ensures brand dominance and sustained pricing power. 4. The global consumer. The consumer is a rare and enormous winner in this technological shift. The silver bomb delivers solutions to every consumer complaint about the current generation of devices. Speed, hyperfast charging eliminates anxiety and inconvenience. Safety. Devices in cars that do not explode or catch fire. Longevity. Products that retain their performance for the full life cycle of the device or vehicle, delaying the need for expensive replacement or upgrades. This is a generational improvement in quality of life driven entirely by the shift away from the flawed lithium bridge. After detailing an extinction-level event, it's critical to introduce a necessary reality check. This transition, the full replacement of lithium-ion, will not be instantaneous. The silver bomb has been detonated in the lab, but the blast wave will take time to propagate through global manufacturing infrastructure. The shift from a bridge technology that has dominated for 30 years to a completely new paradigm faces predictable and immense hurdles. The transition will be a 5 to 10-year disruption window, defined by 3 major challenges. 1. The scaling manufacturing challenge. the current global lithium-ion manufacturing capacity, dominated by Asian giants, is immense. We are talking about gigafactories, massive facilities built specifically for liquid electrolyte processes. Solid-state manufacturing is different. It requires new dry room environments. The assembly process for solid electrolytes is extremely sensitive to moisture and contamination, necessitating entirely new sterile production environments. Retooling of assembly lines. The machinery used to roll and stack thin films of solid electrolytes is highly specialized and requires precision engineering far beyond traditional liquid cell assembly. Massive capital investment. Switching over requires billions of dollars in new capital expenditure, a risk only companies like Samsung and Toyota, who are also pursuing solid-state, are currently willing to take. The transition will be constrained by the speed at which the world can build new solid-state manufacturing capacity. This inertia provides a short grace period for lithium-ion, but it doesn't change the ultimate destination. 2. The cost and sourcing of silver. The most frequently cited challenge to the silver bomb is the cost of its namesake, silver. Silver is currently significantly more expensive than the elemental lithium used in batteries. Critics argue that the cost barrier of silver will prevent mass adoption. However, this argument fails on two fronts. Volume of use. Samsung uses silver surgically as a conductive nanocomposite layer, not as the primary active material. The total volume of silver per cell is small, minimizing the cost impact. The scale effect. Any commodity's price is sensitive to demand. As production scales from laboratory prototype to millions of units, supply chains become optimized, specialized mining increases, and the cost per unit of material inevitably falls. This happened with lithium, nickel, and cobalt. It will happen with silver. Furthermore, the high initial cost of silver is offset by the elimination of other costs inherent to lithium-ion, no expensive cooling systems, cheaper insurance due to zero fire risk, and a longer product lifespan, reducing replacement costs. The total lifetime cost of the silver bomb battery is actually lower than its lithium equivalent. 3. Certification and regulatory hurdles. The battery industry is tightly regulated, particularly in the automotive and aerospace sectors. Every new chemistry must undergo years of rigorous testing for safety, durability, and performance under extreme conditions, crash tests, thermal cycling, deep discharge. The silver bomb technology, being fundamentally new, must clear these regulatory hurdles in every major market, from the FDA and FAA for consumer electronics and aviation to the NHTSA and EU regulators for electric vehicles. This process adds significant, non-negotiable time to the deployment schedule. This 5 to 10-year window is the timeline for mass transition. But the market does not wait for certification. Perception moves faster than production. The moment Samsung publicly validates the technology with a credible partner, investors and lithium producers will price in the eventual market destruction, leading to the collapse we discussed in Chapter 4, long before the first mass-market solid-state EV hits the road. When we talk about batteries, we are not simply discussing a component in a phone or a car. We are talking about the control of the 21st century's core infrastructure. The real story behind the silver bomb is not about lithium versus silver. It is about who dictates the future of energy, transportation, and technology. The control of storage. In the previous century, control belonged to those who controlled the flow of energy, the oil producers, the pipeline operators, the utility companies. The new era is defined by the control of storage. Whoever controls the most advanced, safest, and most scalable method of storing energy controls the future of transportation, dictating the design, range, and cost of electric vehicles, drones, and future electric aviation. The grid, determining the resilience and stability of national power grids relying on intermittent renewables. Data and AI, powering the massive always-on data centers that fuel artificial intelligence and cloud computing. For 3 decades, lithium-ion granted this control to the miners and the manufacturers who mastered the liquid-based chemical process. That control was fragile, relying on unstable supply chains and plagued by fundamental technical flaws. The shift from resource control to innovation control. Samsung's breakthrough is a strategic masterpiece because it shifts the source of power. The old era, lithium-ion, power rested with the resource owners, Chile, Bolivia, and the refining capacity owners, China. It was a game of raw material leverage. The new era, solid state, power rests with the patent holders, Samsung, and the manufacturing innovators who can master the complex solid-state assembly process. It is a game of technological leverage. This is a profound shift for Western economies. Instead of relying on volatile developing nations for raw material security, the West and its allies like South Korea reasserts control through technological superiority and intellectual property. The silver bomb is not just a commercial product. It is a geopolitical tool that reshapes the map of future industrial power. The cost of stagnation. The lithium empire was a failure of imagination. Corporations and governments clung to it because it was familiar, investing trillions into a bridge technology, fearing the transition. The silver bomb proves that stagnation is not stability. It is risk. The failure to innovate creates vulnerability. The nations and companies that adapted to the slow, risky, and dirty lithium standard will now pay the ultimate price, the sudden loss of competitive relevance. Lithium defined the last era of digital infancy, but the next age defined by hyperdensity, instantaneous power, and zero-risk safety demands something better. Samsung didn't just deliver a better battery. They delivered the new foundation of global power. The silver bomb has been dropped, but the smoke has not yet cleared. The industry is now entering a period of massive turbulence, defined by secrecy, strategic partnerships, and panic selling. The key signal is not what companies are announcing, but what they are desperately trying to hide. 1. Quiet partnerships and technology scouting. The smartest companies are not fighting the wave. They are trying to surf it. Expect secret deals. Major automotive manufacturers and tech giants are currently engaged in intense, quiet negotiations with Samsung to secure licensing agreements or guaranteed access to the first commercial batches of the silver-enhanced solid-state battery cells. These deals are happening away from public view to avoid alarming investors in the lithium sector. Government funding shifts. National science foundations and energy departments will rapidly reallocate billions of dollars away from lithium R&D and towards solid-state and silver-based alternatives. This silent shift in public funding is the most reliable indicator that the lithium-ion era is officially over in the eyes of state-level strategy. Companies that are slow to pivot, though still doubling down on liquid lithium-ion gigafactories, are sealing their fate as the next-generation S-market losers. 2. The Great Devaluation and the lithium pivot. The market will move ahead of the product. The transition won't wait for a 2030 launch date. It will be priced in today. Stock market pressure. As rumors solidify in the fact, lithium mining stocks will face a protracted period of volatility and eventually a sharp devaluation as future demand models are revised downward to near zero. Corporate pivots. The only way for existing lithium companies to survive is through radical adaptation. Lithium miners will be forced to pivot to extracting other critical elements needed for the new solid-state supply chains or face massive closures. Battery recycling companies will scramble to retool their processes to handle the new solid-state battery architecture. The smart players are adapting in secret. The slow ones, the ones clinging to their lithium reserves, will disappear into the history books. 3. Increased secrecy and the patent wars. This is a winner-take-all scenario. Samsung holds the master key with its silver composite patent. Expect a global surge in patent litigation as rival nations and corporations try to legally invalidate Samsung's claims or reverse engineer the silver bomb. The next 5 years will be defined by legal battles over intellectual property, not by technical announcements. Whoever controls the patents controls the price, the scale, and the ultimate timeline of the energy transition. The silver bomb isn't loud. It doesn't explode in a visible flash. It replaces the foundation of the previous age quietly and entirely. Lithium powered the digital age, but the next era of hyperdensity, speed, and safety demands something better. Samsung may have just delivered the irreversible final word.